Greetings, students, and welcome to today's lesson. This is lecture 3 in the series for the CM 153 class. I had you listen to lecture 4 on Tuesday when I was unavailable, and today we're going to go through 4 separate modules on information that is, I think, very important for us to learn in this course. So the first thing I want to do is cover a couple interesting economic issues. We talked about last week how important the residential housing segment of the market is to the overall economy. And there was some good information yesterday about housing starts popping up in June. But there is concern for the issue of whether the multifamily home builders are going to be strong in the future, which I believe is the case because we don't have much land prepared for single-family development, or will the single-family home builders become the next boom in the marketplace? So there's a couple things that I want you to see on the let's see if we can get this to work here. Okay, a couple things that I'd like you to see on some major projects that really tie into some of this economic development. And the first one is a interesting video on the Wilshire Grand project that's up.
Hi, I'm Scott Blair with ENR.com, and I'm here at the Wilshire Grand Center in downtown LA with
Mark Turcott from Turner Construction. I'm the tower superintendent on the Wilshire Grand.
Thanks for taking some time to talk with us today. So can you tell me a bit about where we're at in the schedule on the project?
We are about 14 months from the end of the project. We're 2.5 years in construction. We're almost at the top with the core, and we got one more lift to pour, and we're 2 sequences down, like 4 floors down on the steel. So very close to topping out the building and start focusing on the rough end and the finish trade.
So last time I was here was about a year ago, and it seems like you guys made a lot of progress in that short amount of time. Can you talk about the construction pace and some of the strategies you guys are using?
A lot of progress, yes. A year ago, all we had that was sticking out past the street was the concrete core. Concrete core was up to level 26, going through the lower BRB. We hadn't really not started any steel. We may have just been poking out of the street. Now, 1 year later, the core is over just at the 73rd floor, just right at reaching the 73rd floor, the top of the building. The steel is on 69, which is again 4 floors from the top of the building, and we got glass up to level 39. There's finishes going inside. The rough-in is like in full mode. So it's amazing how what a year makes. The difference in a year that we see on the project.
Yeah, and as far as sequencing and keeping everybody on target and going towards the finish line, what kind of strategies are you guys using to keep the project organized?
It's all about scheduling tools and keeping to the milestone. If you aim for the end date, if you keep aiming just for the end date without looking at the different milestones and the different stages of construction, that's just too much to bear, too much to swallow. So we have paces, number of days per floor, and as we go up, you control where you are, you re-accelerate something if you need to, and you resequence stuff if you need to. But right now we're in a really good pace. We're right where we are at the top out, and where we need to be at the top out, and I'm excited about finishing the project. Unlike a lot of the buildings I've worked on, and most of the stuff we build around Southern California, this is a 73-story building. You cannot wait till you're topped out to start your finishes inside. Typically you'd go, 5-6-story building, you go to your roof, you enclose the building, you do your rough-in at the same time, and you don't start finishing until you have a roof on top. 73 stories, in order to start finishes before you're topped out, you have intermediate decks where you basically weatherize yourself on the lower floors in order to start finishes and keep the train of activities going. So we're at level 28, which is the anchor point for the lower BRB of the building. BRB, buckling restraint brace, it basically keeps the building like a skier with ski poles. The challenge about the lower BRB, what I thought was the biggest challenge with BRB at the onset when we approached the project, was the size of the embed on which the BRB is anchored into the core wall. So that BRB is anchored on a 36-foot tall embed. So if you can picture pouring the core wall in lifts, right, and we have 14-foot lifts. When we got to level 26, which is a level down below here, no 27, one level down below here, we had to, at the top of the erection, at the top of the concrete pour that we just did, we had to stand a 36-foot tall embed up in the air, right, in the middle of nowhere, and have it perfectly plumb, perfectly straight, perfectly braced, build all these rebar cages around it, form everything around it, and just pour it and have it stay. So it was more than twice the size of a lift. It seemed like overwhelming. The embed itself is 18,000 pounds, has over 100 number 9s going across to the other side. Very, very intricate work.
We're going to pick up from that point and talk a little bit about what this superintendent brought up. But it's very interesting to look at some of these field visit videos that ENR has prepared. And the link for this one is in the slide deck that's also in the folder for today's lecture. So you can look at that video, and there's two other videos that I have here that I think would be very interesting for you to watch. I think one is a video and one is a really good article that deal with the Panama Canal expansion. The Panama Canal expansion is one of the largest projects that we've attacked in the last 20 years, and it is a significant amount of movement that has taken place, both in expanding the capacity of the canal for the number of ships and the size of the ships that come through. These are very interesting videos. Please take a few minutes and review them at your own time. One of the things that the superintendent spoke about in the project was the amount of concrete that they use for the center core of the building and how it tied into those buckling restraining braces, the BRBs that he talked about in that last segment. Concrete is an interesting topic. Can you tell me the difference between concrete and cement? Think about that, because a lot of people use those terms intermingled. And the truth of the matter is, a cubic yard of concrete weighs about 4,000 pounds. And in that cubic yard of concrete, there's only about 400 pounds of cement. That would be a 4-bag mix. The rest of it is made up of sand and granule and other kinds of aggregate that the cement bonds together to provide the structural material we call concrete. So when we think about cement, remember that it's about a 10-to-1 ratio, 400 pounds in a 4,000 pound cubic yard. So we're going to use the term cement for a lot of this because cement is a product that we have to mine and add energy to in order to prepare it. These are some of the different uses of cement in the industry, and you can look at how it's grown from 1975 to this. I think chart goes out to about 2012. The difference between ready mixed concrete, building materials, masonry cement, concrete products such as concrete pipe that's used in underground for stormwater systems and things like that. For the mining industry, all of these things are shown as uses, but as you can see, the biggest use in this is the ready mixed concrete. In the video for the Panama expansion, you'll find out the number of cubic meters that they used for expanding the locks down at in Panama, and the quantity is quite amazing. If you look at the U.S. world cement production from 2010 to 2014, you can see even after the slump we hit, you can see that the world has still increased its consumption of cement. Remember, so this is in millions of metric tons. So in 2014, the world used 4 trillion, well, I guess that would be 4,180,000,000 metric tons of cement. That means that we probably placed close to 100 times that, or 400 billion metric tons of concrete. So when you think about the uses of cement in the world, interestingly enough, we are just a minuscule portion of it in the United States. And we use it for buildings, we use it for concrete masonry units, we use it for highways, we use it in all sorts of different ways. But the consumption of cement around the world is really quite significant. There's a couple more links that I have here to articles that are in the folder so you can take a look at them, but they are articles that talk a little bit about how the amount of concrete that needs to be moved for major projects can lead to the need to design even custom equipment to both mix, carry, and place that concrete. So I've given you a couple different links in here, and there's a couple different files that are in the folder that talk about the difference in not so much the difference, but the various uses of concrete throughout the world. I think they are interesting to read. Take a look at them, and they'll give you some good background on what we're doing. Concrete in the environment is a very interesting slide deck. It talks about how the volume of energy that is required to produce the cement, and then when you add that to the amount of energy that goes into the mixing of cement into concrete, the transportation of that, and the movement of that material to the job sites, it is becoming a concern for the environmental impacts of all of the use of this cement. So I'm kind of just clicking through these, but take some time and go through this deck of slides yourself. I think you'll find that it is intriguing to see some of the issues that it brings up. And last, the economics you can look for in ENR.com. Remember how I've mentioned that ENR.com is really an important resource for you in this class. But you'll be able to actually see the archives of where building material prices are today. You can look at them for going back, but they actually have a weekly issue of the Economics Weekly that talks about the cost and materials of classes that are, or the various building materials that are out there. Once again, a resource for you to use and a little bit to learn about. So let's get back into the slides here and see what's next. Oh, this was an interesting infographic that I found. In 100 years, the United States, that's from 1901 to the year 2000, the United States used 4.5 gigatons of cement. 4.5 billion tons of cement. In China, in the 3 years from 2011 to 2013, China used 6.6 gigatons. So in 3 years, they used about 140% of what we did during the entire 20th century. So you can see that the cement usage is much greater in other parts of the world. That previous chart showed us that when we looked at the volumes comparative to the U.S. But this one really shows where the significant portion of that material is going. So there's also a great article in a manual on global cement contents of how cement is used. I've also included a copy of that in the folder. And that's the end of this first segment.